Alright guys, in this video we're going to talk about quadratic equations. I'm going to show you one of these. Here's a quadratic equation. Maybe you are familiar with linear equations where you have something like this with the 2 times x plus something else. But now we're going to have another term that's going to have an exponent, the 2. So it's going to have an x to the power of 2. And let me show you the graph for this. Here it is. This is the graph for this equation. Now I'm going to show you also a graph for a linear equation. This is the one that you have been using to solve systems of linear equations that you have been doing for quite some time now. And if you graph it, you're going to see a line like this. Now, what about this quadratic equations? Why do we have them, and what's their use? But before we get into that, I want to show you some terminology. Well, first of all, this number that you have here is going to have a special name. It's going to be called the quadratic term. It's called quadratic because it's going to be to the power of 2. It's just the x to the power of 2 and its coefficient. This is the quadratic term. And you have this one that doesn't have an exponent. Of course, the exponent, it's going to be 1. Doesn't appear, but you know that it's there. We call this the linear term because when you graph a linear term, it's going to be making you a graph when you just do the 2x. So we call that the linear term. But when you combine it with the quadratic term, like in this equation, it gives you a parabola like this. That's what we call this type of graph, a parabola. Now the last term, we call it the constant term. Why is it called the constant term? Because it's 4, or it could be a 5 or a 6 or any other number that is not multiplied by x. That is going to be the constant term because it doesn't change. It stays the same. And this term does change depending on the value of x. But this term changes accordingly to the square of x. So we have these three terms which are going to be involved in all quadratic equations. Alright, we gotta have that in mind. Let me show you some graph of a case where you have, for example, this constant term. The constant term here, it's 4. And when you graph just the 4, it's just a number. That's why we call it the constant term, because it doesn't change when you graph it. It stays the same. As you can see, for 1 you get a 4, for 2 you get a 4, and so on and so on and so on. Now, quadratic equations, what do they describe? What is their use? For example, have you ever thrown a ball? When you do that, the trajectory that it will follow, it's going to be a parabola. And that parabola will be described by a quadratic equation. Now, what else do you have when you throw a ball? You're going to have your hoop. So somewhere along your trajectory, it's going to be having your target, which is this. Now, if the ball keeps on going, you got a 3-pointer, didn't hit the hoop. It's going to keep on going in the same trajectory, and eventually it's going to hit the ground. So you got various points here in the parabola. The most important point is going to be when you hit the ground and also when it leaves the ground. This should be a little bit more down over here. But if it was there, it wouldn't make much sense because you would be at the same level as the ground. But imagine that you were. And you're going to have 2 points that are very important. This point and this point when it hits the ground and when it leaves the ground. Those are going to be basically the solutions to this problem. I'm going to show you in a while. Now, linear equations give you one answer. Remember when you had x plus 2 equals 20 or something like that? You had to solve it and you got one answer. That was it. You just had that one answer. And if you had a system of equations, well, you had to do some more stuff. You would have the x and the y. But you know what? When you have just one equation, one quadratic equation, you're going to get two solutions. You're going to need two answers. That is going to be how you solved it. So it's going to be, for the quadratic equation, it's going to be a twin. You got to get twins. So what is the solution to this? Well, let me show you a linear equation. A linear equation, remember, it gives you just one answer. And when you graph it, the answer is going to be actually the point where the line hits the zero. That's going to be the solution to an equation, actually. And when you have a quadratic equation, the solution is not going to be found just once, because when you have a straight line, it only hits once this axis. But when you have a parabola, it goes upward, hits once, goes upward, then goes downward again. And you know what? It goes back. So you gotta touch again the x-axis, so you get two solutions. Let's get started with the problems. What if they give you a quadratic equation like this one? This equation is pretty easy to solve, but how do we do it? How do we get to that? We gotta do some algebra, guys. We gotta do some adding and subtracting terms. In this case, we got a negative 16. What do we do to get the answer for x? It's pretty much the same as we did before when we had a regular equation, a regular linear equation. Well, you gotta subtracting 16, you gotta add 16 and add 16 over here. So this cancels over here, and now you got 16 plus 0 gives you a 16. What's gonna be next? What do I do with that 2? What is the opposite of getting the square of a number? Well, the opposite, guys, it's going to be getting the square root. So in order for me to cancel that square, I gotta get the square root. And that's going to be just like when you had multiplication, you had to do the opposite. The opposite of multiplication is division. And when you have a subtraction, you gotta do the opposite in order to cancel that term. You gotta add, and so on. So you gotta do the opposite operation. And when you have a square, you do the same thing. You gotta do the opposite operation, and it's going to be the square root. And you gotta do it on both sides. And remember that the square root of x squared is going to be x, because when you get the square root of a number, you're looking for two numbers that are exactly the same, but that when they multiply, it gives you that other number that you had before. So x times x, it's going to be x squared. That's why the solution to the square root of x squared is going to be x, because x times x is x squared. So we get this result. We get this result, x equals square root of 16. Square root of 16, it's pretty easy to get, right? What do? What's the answer? It's going to be 4, of course. Alrighty, guys. Remember that I told you that it wasn't just one answer? Remember, you get twins. Twins. You get two solutions. Where's the other solution, teacher? Where is it? Well, it's right there. It's right there. Remember that I told you that x squared equals 16, right? We had that. And this could also be asked in the following way. You're looking for two numbers that when they multiply by each other gives you 16. Of course, that's going to be 4 times 4. But you know what? You don't just do 4 times 4 to get 16. There's another pair of numbers that are exactly the same, and it gives you also 16. Can you guess which one it is? It's going to be negative 4 and negative 4, because negative 4 times negative 4 gives us positive 16. That's why the solution is going to be x equals 4 and x equals negative 4. Now, when we graph that equation that I gave you, which is this equation, if we graph it, we're going to see the solutions right there. If you, let's see, what do we have here? Where is it? Oh, here it is. This is the x-axis. So each of these squares represent one unit. You have 1, 2, 3, and 4, and then 5, of course. So this is one of the solutions, and this is the other solution at negative 4. So this is like maybe this could represent part of a theme park where you have your roller coasters and you have the roller coaster going in this direction, and you go down and you go upwards again. That roller coaster could be described by this quadratic equation. So you can describe many things with these quadratic equations, and when you get a solution, what you're looking for, what you got, it's going to be when that roller coaster hits the ground, and this is going below the ground. So when you hit that level of the ground at 0 meters, and you want to know what distance you have from the origin from here, that's going to be the solution to a quadratic equation. That's what we had here, x equals 4 and x equals -4. Alrighty guys, so this is going to be a quadratic equation, and as you can see, it only involves a quadratic term and a constant term. All right, not the linear term. Now I'm going to show you a problem when you have a linear term but not the constant term. Of course, the quadratic term has to appear, because if it doesn't, it's not going to be a quadratic equation anymore. So here we have a quadratic equation with the quadratic term and the linear term. What do we do first? What do we have to do? Well, first of all, I gotta move it in such a way that it's going to be equalized to 0, which is what we have right there. And we have x squared minus 3x equals 0. What do I do now? What should I do? Because if I did that because if I did, oh teacher, what if we just get the square root of this thing and the square root of this other one? But you know what? You got a problem right there, because you got an x. And what's going to be the square root of x? Well, that's going to be complicated because we don't know the value of x yet. And we got an x on the right side and on the left side, that's going to be a big problem. You can't solve it with these methods and like that, like it's like that right now. But that's why we gotta clear it. We gotta move it to the left side, and we're gonna do a technique called factorization, which you guys have mastered already, that you guys already understand. But I know that many times we forget things, so I'm just gonna give you a refresher. So this x squared, I'm going to be placing it as what it represents. X squared means the same as x times x. Now, factorization. We got to look for a factor that is common between the two terms. What do you see that is common between this term and this term over here? Between the x times x and the 3 times x. Do you guess? Did you guess? Do you know what it is? It's the x, right? So you got this x that repeats here and here. What's going to be next? Well, you got to factorize it. You got to take it out. Gotta place some parentheses in there, put the x on the outside. So now you're gonna get this. The x is now on the outside, because this is the same as what you had before. If you go backwards, if you do this, for example, x times x, what do you get? You get x squared, or x times x. And then when you do x times 3, what do you get? It's the same as over here, 3 times x. So this and this are equivalent. There you go. Now we're ready to use our knowledge of quadratic equations, guys. The whole point of this is to make it 0. So we just use factorization, but now I'm going to give you, before I continue, I want to ask you a few questions in order for you to better understand and grasp what's going to follow up after the factorization. Okay, let me ask you something. Let's do this. What if we have a number that when you multiply by 2, it gives you 8? What's that number gonna be? A number. What is it? You know the number, right? And now what if I tell you that I want to Find that number that when you multiply by 2, it gives you 0. What's that number going to be? Is there any number that is bigger than 1? Is it a number that is less than 1? No, right? The only way you can get the 0 there, it's if this number would have been a 0. So 2 times 0, that gives you 0. And, well, the moral of this part of the story is that 2 times something gives you this. But the only way to get a 0, it's if this number is a 0. So what if I give you this? A number times a number gives you 0. What are the possible solutions to this problem? Well, you get many numbers, but if you use numbers that are not 0, for example, 3 and 5, you can pick all the numbers that you want. For example, 2 and 100, 2 times 500, 8 and 6, minus 8 and whatever. It's never going to give you 0. The only way you can get a 0 is if one of them is 0. So 0 times the number gives you 0. And the other possibility, if the other number on the right would have been a 0. So 0 times this, that's going to give you 0. Those are all the possible solutions to get a 0 when you have two numbers that are being multiplied. And you know what, guys? What we have right now are two terms that are right now being multiplied. So you see this inside the parentheses, it's multiplying the x. So this x times this x minus 3, they're being multiplied. That is pretty much the same as finding this problem. So having that in mind, just right there, with that in mind, we're going to look for a number that makes this thing 0 and this other number also 0. Those are the two possibilities where you can make this equation to be true, to make it equal to 0. So this x, we know that it has to be 0, right? So that's one of the solutions. We got a solution there, guys. Congratulations, you're done. You're half done. You got one of the solutions. It's x equals 0. But as I told you, it's a twin. You got two solutions. Where's the other one? Well, this x minus 3, I gotta equalize it to 0 because all of this thing, it's multiplying the x. And as I said before, the only way you can get 0 is if this number is a 0. So this number has to be 0. X minus 3 equals 0. What number makes this equation true? What number should I place here in the x to make this equation a 0? Well, I gotta do some algebra here, which is not going to be too complicated, of course, because it's very basic. X minus 3 equals 0. What's the value for x? Well, this thing is being subtracted. I got to add 3 here, and I got to add 3 here. X equals 3. So that means that if I place a 3 here, for example, 3, and I got to put it in both parts, because for one case, it's 0. I mean, for this case, if I do it for this one, I gotta use it on both sides. And if I do this, what do I get? 3 minus 3, that's gonna be 0. 3 minus 3, that's 0. So 3 times 0 is 0. And that's why we use that. Now let's go back to the other one, x minus 3, and then we got the 0. Let's use it with this solution, which is 0. Wait, that was x, okay. Now we're going to use, which I'm just going to change right back again. Okay, x equals 0, I'm going to try with that one. So instead of the x there, I'm going to put a 0, and over here, I'm also going to put a 0 there. So then 0 times 0 minus 3 is how much? Well, of course, that's going to be minus 3. And 0 times negative 3, that's also 0. So the solutions to this equation, x times x minus 3 equals 0, the solution is going to be x equals 0 and x equals 3. And if you put it in the parabola, if you put the graph of this equation, it's going to look exactly like this. That's going to be the solution. I mean, that's going to be the graph that it represents. Alrighty? Now, I'm going to show you another problem where you have this same thing, this same type of problem, another example, so that you can have this more clear, hopefully. We got this problem, x squared equals 6x. What do you do first? Well, you have this being added. You gotta pass it to the other side. In order to do the factorization steps, you do the 6x being added. It's a positive, even though if it doesn't show, but it's a positive. And you got 6x, you gotta subtract it from both sides, and it's gonna be minus 6x. Now this x squared is the same as x times x, and this 6x, here it is. What do you see that is common between them? You got the x, so that's why it goes over here. And then you gotta ask yourself, what values of x make this equation 0? Well, what is it gonna be? For this case, x equals 0, right? For this part of the equation, so one of the solutions has to be 0. And to get the other solution, we get x minus 6 equals 0. And that's going to be x minus 6 equals 0. That minus 6, we don't want it there. We're going to add a 6 and a 6 over here. So what happens over there? X equals 6. You got your two solutions there. We're done with that. Let's continue. Okay, we got this problem. X squared equals 5x minus 4. How do we solve this problem? How do we solve it? Now this one, guys, this one has the quadratic term, the linear term, and the constant term. In the previous problem, we only had the quadratic and the linear. And in the one before all of that was with the, where is it? It's this. This one was the quadratic and the constant term. So now we're going to have a combination of the three. Now we have the quadratic, the linear, and the constant term. What do we do? Again, we got to do some factorization. That's the easiest step to do here. That's the easiest procedure for a problem like this one. And you got to remember how to do this. That was from the previous classes. All you had to do was just look for two numbers that when you multiply gives you this, but then when you add them gives you this over here, this negative 5. So what would those two numbers be? That when you multiply them give you a positive, but when you subtract or add, or actually when you add, it gives you negative 5. Well, of course, that's going to be negative 4 and negative 1. Because negative 4 times negative 1 gives you positive 4. That's why this is going to change into this. This is going to be factorized into this binomial times this other binomial. So we get this result. This is the result for the factorization, but we're not done yet. So let's remember the other step that I told you before, because it's the same procedure. When you do factorization, you're always going to get something that multiplies something else. And it's going to apply the same deal when you're looking for a number that when you multiply it by the other one has to become 0. One of them, this one, has to be changed into a 0. So what do we do? Okay, so this x minus 4, we want to know what's the value of x that makes this part of the equation, this factor, a 0. So it's going to be x minus 4 equals 0. The x equals 4. That's one of the solutions. And the other solution is going to be, okay, let's go over here. We take this x minus 1 and we equalize it to 0. And it's going to be x equals 1. So then we get our two solutions, x equals 4 and x equals 1. That's what we have right there. We have the 1 and the 4 if we graph this equation. Alright, so this is where the equation passes through the x-axis. There you go. Let's continue with the procedure. Let's see, what else do we have here? Well, that's it. We're done with this one, but let's do this other one. Okay, this one also has the quadratic term and the constant term. The constant term is right here, and the linear term. So then what do we do? We're going to do a procedure. Okay, before we do that, we gotta move that -2. We gotta pass it to this side. This is -2, so I gotta add 2 and then add 2 over here, and that becomes this equation. But as you can see here, now we have a 2 right there. And the procedure that I told you before from the previous classes, it's not going to apply over here. It's going to be kind of cumbersome if you want to apply to an equation like this one. And we're not going to get into that. But I'm going to show you another procedure to get the result, the twin results for this quadratic equation. What do we do? Well, first of all, we need to identify the coefficients of each term. So for the quadratic term, there's this coefficient, which is this 2 in red. And for the other term, for this linear term, we have this coefficient. It's not just a 5, not just the number, it's also the sign. The sign goes with the number. And the coefficient, which is just a number without the x, don't put the x, guys. That's not the coefficient. We're going to focus first on the coefficients for this next method that is totally new. I'm going to show you this method, guys. But we first got to identify the coefficients. So let's continue. Now, we got also this other coefficient of the constant term. It's just a whole number. There's no x, so it's just that number. Okay, these coefficients have special letters. This coefficient, the first coefficient, we're going to call it letter A. So this is going to be A equals 2. And then the second coefficient, it's going to be -5. Guys, if this would have been a -2, I should have placed here the -2 as well. You got to put the sign as well for all of them, not just this term, but this is just an example. And this 2, well, that's going to be this C over here. So you see there are two 2's, but they are different, right? I mean, this one belongs to the C and this one belongs to the quadratic equation, quadratic term. So you get your B equals -5 and your C equals +2. Alrighty, guys. So the whole process, before I give you the equation, let me just reiterate to you guys that you need to place the equation that they gave you in this form in order for you to get the coefficients. Now those coefficients, they're going to be used in the following way. I'm going to use this equation, this big equation right there. That's kind of crazy. Maybe you're thinking about this term, this sign right there. What do you do with it? Plus, minus, what's up with that? Well, I want to show you right now. We're going to go step by step. First of all, I want you to identify the coefficients that I gave you in the quadratic equation. So as you can see, you have your A, your B, and your C. And right there, it's also the A. There's the A here and the A over here. And the B appears here in the formula and also here in the formula. You got to be very careful. This negative, I'm going to say this many times, as much as I can, because many people make the mistake of forgetting this negative. So you have a negative B. Negative B, guys, this negative B, it's not because this 5 was negative, because in this example it was negative. We can have more examples where this could have been a positive, but this is going to remain a negative B. Okay, so this negative has to be there. Also this other negative. And you got your A and your C and your A. And this is going to be a B squared. So whatever you put here, when you square it, it's always going to be a positive number. Alrighty, guys, let's continue. Let's see what else we have here. Okay, so we're getting ready to pretty much just plug in the values into this formula. And if you do everything correctly, it's going to give you the correct result. It's going to give you the procedure. You don't have to do factorization or anything else or algebra. You don't need to figure out anything else. Only how to plug in the values into this equation and then to solve it. That's all you have to do. So what I have to do basically is wherever I see the letters, not the numbers like the 4 and the 2, only the letters, on those parts I gotta put some pairs of parentheses. And as you can see, I left the color code. So this C belongs here, this A goes here, this B right there, and so on and so on. So I'm going to substitute the values that I had from this equation into this one. So you see the B right there, here's the B, and here's also the B, but now there's an empty space. And also here, the A used to be there, but now there's going to be an empty space, so that I may, in the next step, place in these values of my quadratic equation. Alrighty? Now over here, what's up with this? What did we do? Okay, so all we have to do is just plug in the values for B, for A, and for C right there. So you see this negative, it's the negative of the formula, and the B goes inside this parentheses. The B in this case was -5. That's why we had a -5 there. And also the -5 appears again over here. You have the A here, so the A is 2, that's why I plugged in this value. You got the yellow parentheses, which represents the C, and the C equals 2. That's why I put a 2 there. And then it says 2 times A. The A, we got a parentheses right there. What do we do there? We got to put the value for 2, which is for A, which is 2. So there you go, there it is. Now this equation, we got to solve it now. This formula, actually, there's no algebra to do there. All you have to do is just apply your PEMDAS, your regular PEMDAS knowledge. Now, what do we do? What should we do first? Okay, let's try this. Let's do first the terms in blue. Those are the ones that belong to the B, that belong to the linear term. So we have a -5 times a negative. Negative times negative gives us +5. Okay, so this changed into a positive because we had a negative from the formula and the negative from the equation. So it's going to be negative times negative, positive. Now we have here -5 to the power of 2. Another mistake that people do when they do this, it's that they just want to square the 5 without the negative. So they say, oh, it's going to be -25. But no, this is parentheses -5 squared. So that means that you have -5 times -5, not just the 5. This parentheses is saying that you have to grab everything inside of it, not just the number, also the sign. So you get -5 times -5. That will be +25. Moral of the story, this thing, it's when you get the square of it, it's always going to be positive. Always, guys. Always, okay? Alrighty, guys. Now we have -4 times 2 times 2, and we have all the other terms. Before I go on, please don't forget, this is the negative of the formula, and this is the negative of the equation. Don't forget. Alright? Okay, then. And we have here -5 to the power of 2. Again, that's going to be a +25. Don't forget that, please. Don't. Alright, I'm going to continue. What's next? What's next, guys? What do we do? Well, we're going to multiply these terms of the A and the C, was it? Yes, that's the A and that's the C. So I'm going to multiply this 2 and this 2, and it's going to be 4. 4 times 4, that will be 16. And of course, if this would have been a -2, -2 times 2 gives you a -4 times a -4. That will turn into a +16. So you gotta be very careful, very careful when you get these results. Alrighty, so you gotta respect the signs, guys. You can't just go around doing equations and ignoring the signs. You gotta use them. You gotta respect them. You gotta know how to use them. Negative times negative gives you positive, and negative times positive gives you know what, right? Alrighty, guys, let's continue. So then 4 times 2 times 2 was 16, and because we didn't have any other signs, positive times negative gives you this negative. What's going to be next? Well, we got to multiply the terms on the bottom. 2 times 2 gives us 4. Alright, so that's pretty much it. What's going to be next? Well, these two numbers, they're just regular numbers. You just gotta, there's a negative in between. That means you gotta subtract them. And that's what we'll do. So we get a 9. 25 minus 16 is 9. And after that, all I have to do is get the square root of 9. Square root of 9 is going to be 3. Okay, so we got this result. As you can see, I took off the positive and the color, but it's the same result to simplify what I want you guys to see. Now, we're faced with this symbol or sign that has a positive and a negative at the same place. What are we going to do with that? What does that mean? Well, guys, it's like in life, you reach a part where you have to make a decision. You got to go in one direction or you can go in the other direction. You got to choose. So the positive and the negative says, okay, one of you is going to go in the positive and the other one is going to go in the negative direction. One is going to be doing the addition and the other one it's going to give you a subtraction. So that sign, guys, it's like a fork. You gotta get two roads. You're gonna get two directions of the procedure. So until now it was only one direction of the procedure. I mean, you just kept going. But now we're gonna have in parallel, if you may, we're gonna get two procedures at the same time. But I'm gonna start with the positive, okay? Why not the positive? I could also done the negative first, but it's the same. Okay, so so this 5 plus 3 divided by 4, 5 plus negative 3, that's going to be changed into two parts. So you get the one when it's positive and the other one when it's negative. So you get these two parts. The procedure is going to be divided into these two parts. Alrighty, guys. I'm going to start with the positives right there. And 5 plus 3 is 8. And then 8 divided by 4, well, that's 2. That's one of the solutions. And the other one, it's going to be over here. Well, now we're going to do the negative of this step. So you get two roads of your procedure. This is the other road. We're going to do 5 minus 3, that's 2. 2 divided by 4, well, it's going to give you a fraction or a decimal. It's 1/2 or 0.5. So you get your two solutions. You get x equals 2 and x equals 1/2. Those are your two solutions. Now, if I place that in the graph, we place it in the graph, and we can see that the parts where the parabola is going to hit the x-axis, it's going to be right here and right there. So those are the two expected solutions. X equals 2, there it is, and x equals 1/2, here it is, x equals 1/2. Now, to make this more clear, I'm going to show you another example with this same procedure. This one is 3x squared plus 10 minus 25. Oh, look at that. This 10, hey, where's the, something missing here. That's supposed to be, let me see, let's put here. There's supposed to be an x, of course. And we're going to put it right now. There you go. Now it's fixed. So you get 3x squared plus 10x minus 25. This is going to be the equation that you need to solve for. I'm gonna use, I could have used the other method of factorization, but factorization is going to be used pretty much for when you have a very simple case, an equation where you don't have a number that is different than 1 over here. I mean, when it's like this, when it's like this, guys, when there's no number here, you use factorization most of the times. And if you can't do it with factorization, because it's very fast, I mean, guys, I mean, you just do this, and then you do this, and all of this. It's very easy when you do factorization. It's pretty fast. Compare that with this procedure, right? It's more long. But this procedure, you have to do it when, for example, you can't do the factorization. So that's going to be a problem, right? I mean, you got to know which one to use. This one, you can use factorization. You could use it, but it's going to be kind of cumbersome. And we didn't see it in the class. You can look it up if you want. But I recommend you guys to use the quadratic equation when we have an equation like this one. But if you can divide it, I mean, if you can solve it through factorization, because there's no number here multiplying the quadratic term, then go ahead. That's the recommended case when you have no number multiplying the x squared. Alrighty. So then, well, let's get the result. Let's get this going, guys. So in the equation, it's always going to be negative b. And the b is right there. That's the 10. So it's going to be negative 10. Alright? So basically what you have to do here, remember the equation? Let me show you the equation again. It's right there. It's right here. It's negative b plus minus square root of b squared minus 4ac. So this b is going to be, in this case, since it was a positive, now turned into a negative. And here you have the b squared. And the b is 10, so it's going to be 10 to the power of 2. Minus 4ac. A is 3. C is negative 25. There you go. Got to multiply this. Negative times negative gives us a positive 300. Got to add it to this. Gives us 400. And then square root of this thing, it's going to be 20. Then you got to do the fork. You got to do the addition. Negative 10 plus 20, that's going to be 10 divided by 6. That's 5/3. And then when you do it with the negative, it's going to be negative 10 minus 20. That's negative 30. And negative 30 divided by 6, it's negative 5. So there you go. We're done with that. Okay, so to reiterate, we have these actually four cases. Let me put the other one. The other case, let me put this really fast. It's right there. Where's the other case? I'm going to show you right now. The other case, it's this one. Let me just copy that. I'm going to copy it really fast, just so that we can have this more clear. Wait a minute. There you go. Here it is. Let me just fix that. And there you go. So you get these cases. These four cases. Okay, let me show you this case. This case, it's when you don't have the linear term, but you do have the constant term. When you have the constant term, all you have to do is pass this guy to this side and then get the square root. The end, you're done. When you have the linear term, which is this case, you have the x without the square and there's no constant term like in this second case, well, you got to do factorization. And it's pretty easy, right? I explained it. You can go ahead and review the video again. And let's continue. Now this one, the other one, these two other cases, I want you to notice that they're pretty much the same category. They're pretty much in the same category because you have the quadratic term, the linear term, and the constant term. Also here, quadratic term, linear term, and constant term. But the difference, guys, it's that this one doesn't have a 2 at the beginning or some number different than 1 in the coefficient. And it can also be solved through factorization in a very straightforward manner. In those cases, do factorization. But when it can't be done by factorization, such as in this case, you gotta use the quadratic formula. The quadratic formula, it's the one that I showed you, that long formula, which is this formula. Where is it? You know the formula, it's right there. It's this formula, alrighty? So that's the formula that you need to use when you have this case. And just to let you know, actually you can solve all these problems with that quadratic formula. But if you use that formula to solve this problem, you're going to take longer if you just do it manually with the other method that I showed you. And also this one. So how would you attain to do that? Well, you got your A, you got your B, and you got your C, right? The A here would be 1. I don't know if you can see my cursor. Do you see it? Okay. So the A in this case, it's going to be, for this equation, it's going to be A equals 1, B equals 0 because there's no linear term, and C would be negative 16. And over here, A would be 1, B would be negative 3, and C would be 0. And then you keep on going with the formula. But the quadratic formula, it's better when you use it for something more complicated. So it's like, if you can solve it with scissors, why would you solve it with a chainsaw, right? Something like that. That would be the reasoning. Alrighty, guys, that's pretty much it. You have a great day, and I'll see you later. Goodbye.